we first of all start with anti-leprosy drugs. Introduction. Leprosy is a slow endemic disease which is caused by Mycobacterium leprae. Mycobacterium leprae, please note this name. It is the bacteria which is caused the leprosy. Mycobacterium leprae. The development of an infection takes many years to become apparent, and the progress of medication has been found to be equally slow. The search for anti-leprotic drugs has been hampered by the inability to cultivate Mycobacterium leprae on artificial media and by the lack of experimental animals susceptible to human leprosy. Now, a method of isolating and growing Mycobacterium leprae in the food pads of milk has been reported and may allow for screening of possible anti-leprotic agents. Various anti-leprotic drugs which are used in the treatment of leprosy. So we list out all the drugs which are used in leprosy as a anti-leprotic drugs. Number 1, hydrocarpets. Number 2, dapsone. Number 3, solapsone. Here is spelling mistake. S-O-L-A-P. P is not in spelling. So, number 3 is solapsone. S-O-L-A-P-S-O-N-E. Solapsone. Sodium glucosulfone. Number 5, sodium sulfoxone. Number 6, promizole. And number 7, acid option. According to our syllabus, we have only 3 anti-leprotic drugs: dapsone, solapsone, and acid option. So we synthesize these 3, dapsone, solapsone, and acid option, in this lecture. We start synthesis of dapsone. Dapsone is also known as DDS. It is the short form of dapsone. Dapsone is synthesized from 1-chloro-4-nitrobenzene. 1-chloro-4-nitrobenzene. It is also known as para-chloronitrobenzene. Para-chloronitrobenzene. If we start numbering from here, ortho, meta, and para. So it is also para-chloronitrobenzene. 2 moles of para-chloronitrobenzene is treated with sodium sulfide, Na2S. Interaction between these 2 mole of para-chloronitrobenzene or 1-chloro-4-nitrobenzene and sodium sulfide removes 2 moles of sodium chloride and give product of di-4-nitrophenyl sulfide. In this reaction, chlorine from here and second chlorine from here and 2 atoms of sodium from sodium sulfide are removed and we get di-4-nitrophenyl sulfide. After this is treated with chromic acid. Here is oxidation unit process takes place in presence of chromic acid. H2CrO4. This is the chromic acid. So, in presence of chromic acid, oxidation process takes place and we get di 4-nitrophenyl sulfone. It is noted that in second step there is sulfide only S, but we proceed oxidation, then it is converted into SO2 and it is sulfone. So in this step we get yield di 4-nitrophenyl sulfone. Then this di 4-nitrophenyl sulfone undertake by reduction unit process. In this reaction, we see there is NO2 group. So this NO2 is converted into NH2. NH2. And our final product 4,4-diamino diphenyl sulfone. It is known as Depson, or we in starting we derive it by DDS. It is derived from its chemical name 4,4-diamino diphenyl sulfone. D from diamino, second D from diphenyl, and S from sulfone. So it is also known as DDS, diamino diphenyl sulfone. Now, industrial or medicinal application of Depson. Depson is used in the treatment of both lepromatous and tuberculoid types of leprosy. It is also used in tuberculoid type leprosy. Please note this. Second, it occurs as an odorless white crystalline powder. It is the property of Depson. Odorless and white crystalline powder. Number 3. It susceptible to discoloration in light. It is also important properties of Depson. It is susceptible to discoloration in light. And last, number 4, although no chemical change is detectable following discoloration, the drug should be protected from light, so it is kept in dark. These are the medicinal application and some properties of Depson. Hello students, good morning. I hope you all are safe and healthy at your home. In our second lecture, last topic is antibiotic drugs. Antibiotic drugs. First of all, we see introduction of antibiotic drugs, and then we see synthesis of chloramphenicol. Chloramphenicol. It is also known as chloromycetin. Second name of chloramphenicol is chloromycetin. So, first of all, we see Introduction of antibiotic drugs. The word antibiotic was introduced by Waxman, the scientist named Waxman, Wakasman, in 1942. The word antibiotic. The word antibiotic was introduced by Waxman in 1942. Antibiotics are chemical substances which are produced by living organisms which can stop the growth of other microorganisms and even kill at very low concentration. Therefore, antibiotics are bacteriostatic. The word bacteriostatic. We have two words, bacteriostatic and other word is bactericidal. So we discuss both in above lecture. So antibiotics are bacteriostatic and bactericidal. The first antibiotic to be discovered was penicillin, well known antibiotic drugs, penicillin, and this is discovered by Alexander Fleming. Alexander Fleming, and this was discovered in 1929. 1929. The first antibiotic named penicillin was discovered in 1929 by Alexander Fleming. Since then, large number of antibiotics have been discovered. Their structures established and many of them have synthesis also. Antibiotics are chemicals, chemical substances, and most of them are optically active because of complex structure. Their synthesis is not commercially useful and most of them are manufactured by biochemical methods. Some antibiotics are active against gram-positive bacteria. This is also we discussed in above lecture. Gram-positive bacteria, and some other are active against gram-negative bacteria. Gram-positive and gram-negative. If an antibiotic is active against both gram-positive and gram-negative bacteria, then it is known as broad spectrum antibiotics. Broad spectrum antibiotics. And we see modern definition of antibiotic. Now we see modern definition of antibiotic. What is antibiotic? It is a chemical substance produced by or derived by living cells, which is capable in small concentration of inhibiting the life process or even destroyed or even destroying the microorganisms. So this is the modern definition. What is antibiotic drug? It is a chemical substance. It is a chemical substance produced or derived from living cell. Produced or derived from living cell. So we synthesize or we get it by biochemical methods, which is capable in small concentration. There is a big benefit, small concentration of inhibiting life process or even destroying the microorganisms. If our body required totally destroying, then antibiotic destroy total microorganisms, and in some cases it stop only the growth of antibiotic, then it inhibited the life process of microorganisms. So in modern time we see antibiotic is a chemical substance produced by or derived from living cell, which is capable in small concentration of inhibiting the life process or even destroying the microorganisms. In this class of drugs, we have only one compound. We have only one compound, and name of this compound is chloramphenicol. So first of all, we see the synthesis of chloramphenicol, and then we discuss its medicinal application. So in second unit we have only one last antibiotic drug is chloramphenicol. It is also known as chloromycetin. This is only antibiotic which is commercially produced by synthetic route. The synthesis of we see the synthesis of chloramphenicol. This is only one antibiotic, and remaining are manufactured by biochemical methods. In this method, microorganisms and chemical process are combined each other. But chloramphenicol is the only antibiotic which is commercially produced by synthetic route, and this compound is synthesized from para-nitroacetophenol. I write the structure of para-nitro. NO2 nitro group and COCH3. This compound is known as para-nitro-acetophenol. This compound is underground bromination. So Br2 treated and we get here hydrogen is substituted. So CH2Br is produced. Now we treated this compound with HCl with present of ethanol. So it is known as ethanolic HCl. We get our compound brominating group is substituted by amino group. So NH2 is introduced. Now we takes place acetylation with the help of CH3CO twice O. It is known as acetic anhydride. So NH2 is converted into NHCOCH3. So we get NO2 benzene ring COCH2 and NH2 is converted into NHCOCH3. NHCOCH3. Now we treated this compound with alkali methanaldehyde HCHO and in presence of Na2CO3 alkali methanal. So we get NO2 COCH. Here one hydrogen is substituted by CH2OH. So NHCOCH3 and CH2OH. CH2OH. Now we treated it with aluminium isopropoxide. Aluminium isopropoxide. It is known as ALIPO and structure of this compound is CH3 twice CHO thrice Al. It is known as aluminium isopropoxide. Aluminium isopropoxide. So this reagent ALIPO, you all are studied it in semester 2. So this carbonyl group or ketonic group is converted into alcohol. Here this carbonyl group CO is converted into CHOH. So ketone is converted into alcoholic group NO2 benzene ring. CO is converted into CHOH and remaining compound are CH, NH, COCH3, CH2OH. Now this compound here are about some reactions. I write further here and then we start our synthesis, remaining synthesis. Now this is treated by HCl. Partial hydrolysis is introduced. So this NHCOCH3 is converted into NH2. So we get NO2 CH NH2. Partial hydrolysis applied and we convert NHCOCH3 into NH2, and now this compound is treated with two reactions. First of all, we resolve this compound and the reagent CHCl2 COOCH3 applied, and then we get NO2 benzene ring CH and our NH2 is converted into NHCO CHCl2. So here is CHCl2 and remaining OHCH2OH. It is known as chloramphenicol or chloromycetin. So this is the synthesis, and we repeat here, I repeat here, this is only one antibiotic which is commercially produced by this synthetic route. By this route we get chloramphenicol or chloromycetin. Now we see the medicinal application of chloramphenicol. Chloramphenicol or chloromycetin is a broad spectrum antibiotics. Broad spectrum. We discuss broad spectrum antibiotic because it is active against gram positive and gram negative bacteria, some viruses. It is especially used in treatment of typhoid fever. Typhoid fever. In typhoid fever, it is especially used chloramphenicol. It is also used in combination with streptomycin. Streptomycin is the second antibiotic compound and it is manufactured by biochemical process. Streptomycin for the treatment of, I further repeat, it is also used, it combined with streptomycin for the treatment of other infection due to bacteria. And last, it also gives good result in treatment of bacterial meningitis. Bacterial meningitis. In some cases, there are bacterial meningitis in patient, so chloramphenicol give good results with treatment of it. These are the medicinal application of chloramphenicol. Here our second unit is now complete. Thank you.